Stream is live. Here we go. Okay. That should work. Whew. Play and run. Still failing. There we go. Okay. Movement equals this for I in range when. What is it? So it's 71, 70 to here. How many cells is that? That would be 20. Okay. Then for J in range when result I movement dot append result I J. There we go. And I'm going to do... Okay, well, actually, I'm just going to do IJ just for simplicity, and then we're going to do area equals result area equals result 50. Is that right? Third to the last index. I went from the right into the last index. Okay. So if I just do print area and then print movement, let's see if this works as intended. Oh, it's result I plus 50. Also, this should be, maybe it's 50 further. Okay, that's correct. Starting from the top, goes all the way to the bottom here. Cool. Does it end in, the input end in V? VV right. Nope. Why is it ending down, left, down? I'm going to do find, I'm going to do VV, whoa, VV up, V left, V. I want to find the last one. I don't know what's stopping there. Oh, it's I plus 50. That's going to be correct. It's also really small. Up, down, down, right. Up, down, down, right. It's up, down, down, right. Cool, 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 cool. Okay. So, this is good. And now, here's what we do. We do robot equals 0, 0 for, and actually here we could also do if cars equals, what did it say the robot starts off on as here? Equals @, then we're gonna take robot 0 equals index robot 1 equals it's probably like this, right? And then let's just check it. So just do print area robot 0 robot 1. Did I go backwards? No. Ah, shit. No, because it's appending cars as a list. Okay, so for in cars, for, nope, it's for J in range len cars. If cars J equals that, then robot that equals row. I don't know why we have index and row in data into rows. Nowhere here is the term index actually used. Yeah, so it's just J. Oh my god, are you kidding me? It literally just says to use a empty. Oh my god. Okay. Len value equals 0 or not equals 0, then do this. Oh my god, fuck off! Don't use data frame stuff make them arrays. Whatever, that's fine. No, we're not doing a bunch of checks. No. I still want one variable holding all the inputs. Using the cells function on C. Which always is. That's good. Okay, cool. Why? What? How is it different than expected? Why are data frames so garbage? No, just... What do you mean it's not subscriptable? Fine, fuck it, we'll do that. To make me import pandas. Okay, here we go. We now have, if I just print area, the join area. Python function notation. Okay, I'm gonna do if check dir equals 0, we're gonna call that north. Then we're gonna do cars or return area. Well, does Python support? Oh, it does, but I have to put it in. Return So then we're going clockwise. Okay. So what was the actual question then? It follows all the instructions. I'm going to do it for step in range len movement. Then what I'm going to do is if check direction row column push direction equals dot, then what we'll do is we will say if check dir equals that, then Area. Okay, then we have to do this again. If push dir equals 0. But what I want to do is if. So it's looking to push. So we basically say I'm going to put the push tile in this function. So if push tile, or well, if do like this. Oh, actually, I do need to do this nested one. If area row call equals that, return true. Saying you are free to push into this tile. Or no, because it'll check dir first, right? So so it will check tile. And if check tile is a circle, then you pump it into push tile. So we're already assuming, so let's just say assumes input is O. So push tile or push into equals this. If push into is empty, then if you're pushing into an empty tile, then you make the next area the push tile, and you're going to return true. Equals yeah, we'll just assume it's an O for now. Actually, no. I don't even need to. I could just say equals push tile because I could put in this later. Yeah, that should work. Okay. Return true. This should be capitalized. Return true. Return true. L if push into equals a blockade, like this, then if push direction equals 0, then we'll do moved. Yeah, block moved equals push tile row how do I make 1 and 3 return nice numbers? But I can't figure out. We'll do it this way. Bit messy, but whatever. Push tile, row -1, call dir, or it's push dir. But now we've now moved over 1. This is row +1. This is column +1 with no row change. This is column -1, no row change. If block moved, this. So if block moved, then you do this and return true. Else return false. And then lastly, after all of this, return false. Four-step and range line movement. If movement step, so I need to do robot, right? Dir equals 0. Okay. Then dir equals 0. I shouldn't need to define it here because it's going to be defined in every single one anyways. Then if it's this, dir equals 1. V left 2, 3. If moved, then whoops. Then, after the robot's finished moving, what's the sum of all the box's GPS coordinates? For I in range len area or j in range area I, EPS top equals 0. If area ij equals O, GPS total equals 100 times I plus J. One J minus 1. On the top left and bottom, got it. And then that should just work. Oops, yes, you're right. I did forget to thank you. That's not correct. Oh, fuck. It's not push tile. This for each of these as well, because it's creating a bunch of boxes when it should not be. I understand the issue. What? Oh my god. I don't know what I have. Just join function, okay. Oh, it's dot join. We're gonna take this. We're gonna see if we can find. Nope, I need that. There it is. Okay. Oh, it should be plus equals. Whoops, that's my mistake. There we go. That's a much more realistic number. Didn't pass the smell test, and that's not the right answer. Okay. So now we got to figure out why. Okay. So I am actually going to change and put this in. I want to see what the end result is. So instead of 50, it's going to be range 10. It is changing things, right? Okay, we're going to do right in line here. Oh, movement. Let's actually put this one in. How many is this? Oh my god. That one's 8. Where else are we putting 50? Okay. Use the initial state. I have that. Cool. Move left. Why did I move up? Why did this move up? Oh, I have the wrong fucking input. Okay, What? Oh, I need to, why is movement... The fuck? Okay, we're gonna copy all this, and I'm gonna refresh this page. This seems like it's bugging out. Alright, something like that happened before, that's new. Okay. That's what I expected. Is this end state the same one? Yes, it does have the same one, as a matter of fact. Question is, does this one have the same? Size equals 10. So the final state would look like this. Ooh. Oh, because I have to do the... Yeah, I should do it after the movement. So it does like movement, and then here it does that print. So then I can actually compare the end state here. Yep, 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 all around. Okay, so all I gotta do is put in my puzzle input then. Is the sum correct? That's actually a question I should also check into. Print GPS total at the bottom. 7971. Okay, that's wrong. Why? Oh, to the edges of the map. So I don't have the -1 here. 1092. Oh, for fuck's sake. Okay. I just can't fucking read, apparently. Oh, it's having a good think. Okay, so I don't need these. And I don't need these, which are incredibly slow. I also don't need those. I needed them for a bit. Don't need them anymore. 150-9863. So right answer, part 2. Lionfish use your information to find a safe to find a safe moment to swim in and turn off the malfunctioning robot. As they start preparing a festival in your honor, reports are coming in that a second warehouse robot also malfunctioning. Warehouse layout is surprisingly similar to the one you just helped. This one's difference everything except the robot is twice as wide. The robot system movement still doesn't change. Hit the wider warehouse map to start with your original map, and for each tile, the tile is that the new map contains that instead. Okay, the title is O, the new map contains that instead. If the title is that, new map contains ... instead. Title is that, new map contains at ... instead. So new warehouse map that's twice as wide and with both boxes that are represented by that. And from before, we now look like this because boxes are now twice as wide, but the robot is still able to put. So speed box can be aligned so that directly push 2 other boxes at once. For example, consider the situation. After approximately resizing this map, the robot would push around these boxes as follows. Cool. That's fucking awesome. That's super cool. Okay, so at the very beginning here, range size -1. If well, okay, I'm gonna. Here we go. Cool. If area I equals 4. It's actually size range. Then now I've got to determine if it's pushing upwards. Okay. So we're pushing a block like this. We're pushing it upwards. So from below. Then we have to do check block is equal to check dir row -1 call push direction and then check block right is row -1 column +1 push direction. Okay, and then if check block L equals dot and check then we push. If check block L equals wall or check block R equals wall. Then return false. So there should not be any other situation besides those two, right? block moved equals so this is the left one. Okay. I'm going to do, we're going to have call comp equals 0, row comp equals 0, and then we're going to have row dir equals 0, call dir equals 0. I'm going to use this exact block for everything. We're going to have call comp equals 1. So equals 0 or push dir equals 3 equals 2. Then we're pushing upwards. Then we're going to do if push dir 0, then we're going to do row direction equals -1. If push dir equals 2, row dir equals 1. And then we can remove all this junk here, making it significantly cleaner, and now I can just check accordingly. So checkbox left equals row plus row dir plus call comp. block this, and then check block other. Okay. Check block this equals dot, and check block other equals that. Area row plus row direction, column. So this is this block becomes this block plus call. If check block this equals that, or check block other equals that, else. Then make a new variable called block moved. Check block this is check block. Well, this should be okay. Other equals this, or check block. So this now covers the vertical case, and now we just have to cover the horizontal case. I don't need to put in this if anyways, but I'm going to. So let's just do that. Okay, cool. We're going to do the exact same thing. Column direction. If it's 1, it's going to be 1. And then if it's equals to 3, then column direction equals -1. I'm just going to copy this entire block, even though I know it's not going to be correct. That's fine. Check block this. Well, if we're going left and right, we don't even need the check block other, because we would know if we're pushing left and right, we have to be pushing on the entire thing. If push into so then we can just get rid of that block. Just remember that. So if it's dot, then we can do okay. I can fix this later. Don't need to worry about it right yet. But that's the if it's dot, if it's that, cool. So now we're going on assuming that we didn't have a return. which means it's only one of these two values. So if we're pushing into it and we're pushing right, if push into does not equal let's push into. This is just to make sure I'm not missing anything dumb. But if we're pushing left, we should always be pushing into one of these if we've made it this far. So check block. Check, actually, this case, call direction will be 2 or -2. We're compensating. There is no vertical compensation we need to consider. It's just column plus call direction. Check block equals dot. Then area row, yep, call plus calder. We just do the exact same thing. Calder over 2 equals whatever it currently is right now. This is just going to be like -1, but it's dividing by 2. It just means you shrink the... It's fine. Okay. If check block equals a blank, return. Else, it should only ever be this. Actually, it could be either, right? It wouldn't make a difference. Because the only reason why it would be like this is if we're looking at it one by one. Block moved equals block moved. I'm just gonna make it doesn't need to be and push tile. Let's just push tile. In fact, I could probably make this an elif. I think that would just work. If it's not row dir, it's row call plus calder push direction. If block moved, then we do the exact same thing again. And then return true. Else return false. $126 on my parenthesis. But if it's a dot or it's a square, then we're done. Oh. What? Oh, not... fuck. God damn it, I'm just dumb. Okay, so let me just make sure I'm making sure here. Okay, so this is still wrong. Because what it actually is new area equals this. If area equals that, two times I, well, it's actually just, 2 times j is that, and then 2 times j. Okay, so here we go. We do this with all of them. I understand. It's not area. It's going to be new area. Oh, gosh. I see what the problem is. Okay. So if it equals bam, then it's dot equals dot dot. If it's at, it becomes at was this, and we're going to do new area dot or I dot append and then we do it again. I'm going to call this old area, and we're just going to call this area now, because it'll actually make it a little bit easier for me to work that with that way. Fuck. Okay. Okay, and we're going to change old area is equal to results that. Cool. Yeah, it should just be 2 times j. Okay, we're getting somewhere now. $161 index out of range. Okay, let's just see what happens. Not what I meant to do. I meant to do this. Okay, let's get 1 in. Okay. First thing is to move up. This is after I moved up. Okay. So I guess the next one is to move left. Up. Let's move right. Right back where I was there. Up. Then left. Then up. I'm with it. Then right. Yep. Down. Yep. Then up. Then up. Then up. down, then right, okay. Then left, then up. It's not doing anything. Then left, then up. Okay, I'm getting close now. Down, then up, then left, okay. I'm in a position where I could do something. Then right, then left, then right, then left. I'm still in the same fucking position here. Then up. Okay, here we go. So were there 4 in a row here? Okay, so it looked like this. Up movement happened. And I took over the tile entirely. So did I fuck up with, if it's empty, then filling it properly? I did. Ooh, okay. Okay, so push into is left. And movement's up. They should both return dots. Row area, row plus row direction, so -1 equals area, row column. And then the row column was being entered. Ah, okay, wait a second. Yep, push direction. Okay. I'm with it so far. Oh. It's too higher than where I am right now. So yeah, right now it's saying, okay, they weren't both this. So I'm pushing into a block. So I'm pushing into a block. Which means I want to check the direction above those blocks. If that's the case, row plus row dir plus row dir call equals area row plus row dir call. Okay. It shouldn't be push into. It would be push tile. So if the current tile is that, then we account for it, but not push into. Per tile equals area row call. If per tile equals this, then call comp equals 1. If per tile equals this, then call comp equals -1. This should be LF just for LF per tile equals at call comp equals 0, else print why is this being called? Because it should be calling the current tile we are. We're pushing into space. what I want to do is I'm going to come here. We're going to make a push into, push other into. Row call plus call comp. Push direction. If push into equals dot and call comp equals 0 or push other into equals dot this. This is row dir equals -1, call dir equals 1, row dir equals 1, call dir equals -1. We remove the return true as well. Okay, that's better. And then return true. Okay. Okay, but we also want to do if call comp does not equal 0, then we've already said that it's equals dot, so we're moving it. This is assuming that it's moving into, that it's either the @ symbol or both are moving into dots. This is an easy case. You're a row plus a row dir plus calder, not minus row calder. Plus, whoops, comp equals row call. Area call plus call comp equals dot. And then return true. Okay, so this is the case where either moves into, actually I'm going to make this into a thing right here. Either moves into a dot, or moves vertically into dot. That's what that does. Now we have to consider, this is the easy movement. This is the blank movement that we're gonna have to care about. So else if push into is this, which means we're hitting something. Where's that? Then call comp is -1 because we're now caring about the left side, and then we're going to be caring about the right side. The issue is going to be what happens if we double compensate. That shouldn't be a problem, right? Oh, it will be a problem. No, it won't, because it's going to be a dot afterwards. If it all resolves out well on the left side, then it shoves the whole thing forward, and then it's going to be a dot there, and it's going to resolve correctly. This happens to work out well anyways. So, okay. If push direction is 0 or 2, if it's up or down. Now we have a situation where it's up and down, and it's not a dot. Check block this is you check the direction of row plus row direction. So the tile above this one, and then the tile above if it's going up the other one. This is not needed anymore because this is already being covered. If one of them is a blockade, then break it. Otherwise, if it's not a blockade, then we just need to delve deeper. If check block this is this, or check block this is that, if it's one or the other, then block moved equals that plus rotor plus column compensation, and then if block moved, and these are not else's, we have to do both of these. But this is going to do a whole, because we're calling push tile, we're doing a recursive function all the way through. If block is moved, then the compensation is done. We replace it with a dot, return true. This will only get checked if the other one is already done. So if there's another block directly above it and it works, it will have already been moved. And then we can slide up. Ooh, that's a problem. No, it's not a problem, actually. Yes, it is. Oh, shit. Fuck, that is a problem. Okay, here's why this is the problem. What happens in this following situation? Where I have this here, this, so what it does is it checks here and says, we have to check the left and then the right. Cool. But what it does is it checks the left and says, cool, slide that up. Because that's part of this push tile. I'm going to make push pot tile take in its own Boolean. And if it is false, it means don't actually do this. Do push bool. If do push, then we do this. But we still return true anyways. Okay. If do push, then we do this. That's why it's causing errors. It's going to be breaking them apart eventually. Okay. We haven't even finished this yet, but okay. So, false. False. If block moved, and if do push, then oops. But now this is true because we actually want it to do the thing. And we're just putting it into a dummy variable that does not matter. We return true regardless, and we return false regardless. Cool. Now, if it's left or right, if push direction is right, column is 2, because that's the tile that we're going to be checking. And yep, cool. And push direction is 3, means we're pushing left. Calder equals -2. We should be pushing into this. Got it. Check block equals check direction in that direction. Cool. If check block equals dot, then if do push otherwise. If check block equals that. Else if check block equals this or this, then block move equals push tile false. If block moved, then actually we could probably put in true and we would be safe here. Actually, I'm pretty sure that is safe because there's no way that it can split across multiple different things. We only care about that if it's pushing upwards. $176. Oh, yeah, sorry. That's right. True. Actually, it should be... Yeah, because we are actually trying to move up right now. We're not just checking to see if we're allowed to move. We are actually trying to move. And if moved, then we do all of that. Okay. List index out of range. What? Why is this being called? Okay, well, let's see if I can find... Oh, yeah. Things are getting split. Okay. Where is the first split? Let's do a control copy. We are going to try finding where that is. Let's scroll down a little bit before we start reaching a point where it might actually start pushing things. Remember, it took a surprising amount of time before it started pushing. Left. Left, and it goes back and forth a few times. Now. Okay. It still ate it anyways. It should not have eaten it. This is what I see here. So this should be the upward movement where they both are dots. Oh shit, wait, this is just... Okay, so first it comes in, and it is the @ sign. No column compensation. It is not pushing into a dot because it's pushing upwards. Let's actually put in the push or the check tile function. Actually, well, if it's 0, -1 row, 1 is +1 row, +1 row, -1. Okay, that makes sense. Yep. So it does the loop. It sees that it's an S sign. It's not pushing into the dot. So it comes here. It's pushing into a left symbol. So column compensation is 1. Push direction is 0. Row direction equals -1. Check block this. Equals check direction, row plus row direction. Oh, wait a second. Wait. Okay. We start with the at symbol, and we come down to here. We have the column compensation of 1. Check block this is the one that we are pushing directly into. And this is the other one. Neither of them are blocks. The first one that I'm checking is a left block. So block moved is block moved and push tile. Row plus row direction, which is row -1. So that's the left. That is whatever block this is. Column push direction false. Okay. Okay, so column comp is for what I'm pushing into, not for what I'm pushing. So I don't even need this. Doesn't do anything. Yeah, this is pushing if I'm pushing into it. If push direction is 0 or 2, so in this case, if it's pointing upwards, push -1. Also, I want to change the robot. I'm just going to do for in range 25 because that should help it print a lot faster. Wait, what? The one that it eats? Tile it is. This is the one that it eats the tile. So it reaches here. Push direction is 0. Row direction is -1. Row plus row direction. So minus a row with the same column push direction. So let's do print check block this. Check block other. Aha. Why? It's saying they're both dots. In the check direction, I'm going to make a thing here that does. Well, I'm not even sure what else I could do, right? Like, if it's 0, print one above it. Unless something changed partway through here. Is there a desync? It could be a desync. That might be what it is. Let's check with... No, it knows where the fucking dot is. Wait, what? Where? Why is... Oh, this is missing. Um... Wait, what? Oh, wait, why is it even making that far then? Print. Test. So for some reason, it's not entering in there. Okay, so this is saying test 2. Oh, when does it print the direction? Does it print the direction after the fucking... It prints that thing very, very last. But for this one, did not print it. So why is it skipping? Because it sees us walking into something. Let's start with this. Should be the exact same. Dope. Okay. I can get rid of that test because now it's going to work as intended. I now need to put in a dot case, but moving upwards. If the push direction is north, row direction is -1. Check block this. So right now we're in a situation where we know we are walking into a block. Our current guy is walking forwards into a block. Yeah. Well, I don't even need this because we're just assuming it only does that. Cool. We'll fix this with the 0, case afterwards. So if push direction is 0 or push direction equals 2. If push direction equals 0, then you get the row direction compensation. Check block this is check direction, the one directly above it. Now, why is this the case? So, let's do... What? Ah, sorry. Row plus row direction. This should give me, yeah, plus call comp should give me the right brace, right? Yes, it does. So check direction, row plus row direction. Ah, no, we don't want row plus row direction. Yes, we do. Yeah, that's where we're checking. But I don't want to check that direction. I just want to check. Yeah, no, okay, whoa. We just do this. Again, there's going to be a big error, but it's just going to be broken sideways. But this is now checking the tiles directly above those, which is not what we want to do. We're just pushing into these. We shouldn't be checking these at all. We already know that this specific tile that's going to be going left, it's going up, is walking into one of these. So we are a block pushing into another block. All we need to do is now say, because we are already walking into a block. That's the whole situation we're in right now. Block moved. Yeah, because anything else we've already covered, right? That's the only thing that matters otherwise. We are a single tile we care about right now. We don't care about the other ones. Just a single tile walking into a block. We have to now look at the two possible situations of the block. Block moved equals push tile, row plus direction, column plus compensation. This one does not have column plus. This is the first one is just column. Push direction. This one is plus column compensation. False. Cool. None of the rest of this matters. If block moved, and then it pushes, then we will say actually instead of false, we could do push. Oh, no, actually, I shouldn't do push. Because we want to only push after we've double-checked that both are allowed. So, we can just do this. This will change nothing. Area, row, they're in right now. So reduction column equals that. We don't need to do the column compensation. That's only for the row we're checking, not for our current row. Never mind. We do actually have to check that. Okay, because if we're pushing up, we are going to be doing push tile on both of those individually, and that will be moved. No, we're not checking on it. We're not checking the other tile. We're just doing our own. Okay. Big error. I get it. Okay, let's start from the very beginning and just see when it dies. That is not where it starts, is it? Left, right. Is that how it starts? It is. Left, right, up. Pushes it right away. But it didn't push it at all when it should have. If per tile equals dot, then return true. Okay, let's start from the very beginning here. Goes left. It moves right. Then it moves up, but it doesn't move that up. Okay. But it just stops it. Okay. So this is not the case. We're pushing into left, and it does 2 checks. Where does it do test? Test. Okay. Let's just do a print push into. Make sure that's doing what I expect. Pushing it to the left, and then it's pushing into the dot. But it should be running this function twice. Okay. Push tile, row plus row dir, column, push direction false. It prints true. So in the first loop through, it does it as intended. But in the second loop through, where it's coming in as a left block, no. Push into equals check dir, row, column, check push direction. So no, that's not coming in. Okay. Column compensation is 1. Print push into is a dot. Push direction is still 0. So row direction is -1. Print up. Cool. For some reason, this is returning false. Oh, wait, because column compensation should be 0, right? Oh, wait a moment. Is that what it's doing? Okay. I get it. If call comp does not equal 0, then block moved equals block moved and So why is it returning false? So we have the left block. It has free movement upwards. So column compensation is correct from the first loop. And then it says now the next one's pushing into a dot. Column compensation is 0. That's true. But then for some reason, it's saying block move equals push tile, row plus row direction, column push direction false. At left block, this. So it's returning true. In theory, right? Why is this returning false? Okay, so wait a moment. This is returning false on the initial call. This is ordered the other way around. Okay, so print call compensation happens. Yeah, so that's why it does this, and then it does this, and then it does this, and then our first. So we're going all the way through here. We reach here, we print the comp. Cool. We now reach this first block, and it iterates. We then come in through, and it prints block moved. It does do block move exactly as intended. True. Then it comes back out. Comes back in. And does... Well, we're only printing it... Am I printing block moved? Okay, so let's remove call comp push into. Just do this. Okay. So the first time it comes by, it does this function right away. And the next one does this function, gets true, and comes and puts in true. And then the second time it comes here, it is 0. So for some reason, this, in our first iteration, is returning false. So the right block is returning false. Row plus rotor. Okay, so let's do... It's this. Because we just had a proof that that block move came back true, right? Oh, wait, sorry. If block moved... Oh, shit. That's what I fucked up on. Okay. It's this. Oh, it actually moves up correctly. Okay. Wait, that actually moved it up correctly. Okay, wait. Okay. Let's get rid of the cringe prints. Upwards, moves it correctly. Left, moves it correctly. Right, moves it correctly again, up, moves it correctly a second time, left, up, right, breaks everything. Okay, right? Let's just check. Okay. So, now we actually need to make sure that the right works correctly. Did it screw with big error? It did not. So pushing 1 is right. Check block equals check direction, call plus callder pushder. So if we're right, we know the situation is whatever we currently are. We are a thing that's being pushed against, or the robot. And we want to check 2 away, always, or no. Yeah, because if it's pushing into a block, into a hash, it's already failed. So we right now are a left block being pushed into. That is what the push into is right now. We're a left block being pushed into. Cool. I think the issue here is, okay, if check block equals this, if do push, okay, so if check block equals dot, well, so we're already considering the case where we are the add we've looked on into a dot. So this is pushing the thing forward. And if that's the case and it's a dot, then cool. If it's pushing into a block, either we are a block ourselves. I'm working on this right now because I actually think I can finish it at a reasonable time. This is I've gotten the up and down movement correct. I just have to figure out the left and right movement, and then I've done part 2. This is a fucking great question. It's horrendous and evil and great. It's another one of my favorite problems we've had so far. This is actually kind of annoying because there's 2 circumstances. Either we're looking at, okay, we're just going to do Calder 1 and Calder -1 right now. So what we're going to do is, if cur block equals, or cur block equals, then Calder times equals 2. Cool. Check block. So we are either, if we're going left, so we're from the left to the right, we are either looking at the cell right next to us and seeing the block is cur block is, or cur tile is what I should be looking at, sorry. Not cur block, cur tile. So if we're the we're looking at the tile next to us. If we're the left block, we're either considering we're a left block being pushed to the right, we look 2 over them. Check block equals check dir, column plus calder, push direction. Cool. If check block is a dot, if do push, if calder equaled, or if absolute of calder equals 2, then area row column plus call direction, so plus 2, is equal to the one right next to us. And area row column next to us becomes us. And then area row column becomes dot. That's all we need to do there. Else if check block equals that, then return false. If check block is the right or left block, Oh, and then I should do elif abs call direction equals 1, then yeah, cool. If the check block is that again, then block moved equals push tile, row, call plus calder, push direction, true. Do the exact same thing. If the block moved, so yeah, we are assuming that we are either an at pushing onto the right, or if we're left on the block. So if check block equals dot, this cannot happen if we're at. So I can just remove this entirely. That, and we're pushing onto a block, or yeah, so we've already established the column direction is +1. Block moved equals push tile, row plus column direction, or row plus column direction. Yeah, push direction. If block moved, then if abs call direction equals 2, then we do all this shit, but not this one. If abs calder equals 1, area row call plus column direction equals area row column, and then area row column equals dot, return true. If do push, then this. I didn't add that in before, but I should have that in every time that we're doing any manipulation. Regardless. Okay, so is there a do push check for this area? Check. Is there a do push for that? Yep. There is a do push. So 120 is invalid. Why? Oh, double equals. Okay, so first up push. Push the block successfully. Left, right, up again. Push it correctly. Left, up. Big error. Why? What? But it's correct. It pushed it correctly. You're faster than me on part 1. Fuck off! I'll take the tie today. Okay. Well, does it break at some point? It's got to have like some broken shit, right? No, there's no broken shit so far. I guess all that does is that so far, right? But why is it checking here? There should be no... Oh, no, it's not push into. It's cur block. If cur tile That's what it should be. That's my sanity check. But now we change from 25 to Len movement. $159, index out of range. What? How is Robot 0, Robot 1, or Kurd? How is this out of range? What? What? I don't understand. Uh... There's 20,000. 6191. List index out of range. How is this where it fails? What? I'm not making an index call. What? List index out of range. But I'm not calling a fucking index that isn't already here. What? I'm so confused. How is this? What? Maybe if I do this, it'll fix it. Maybe because it's seeing that there's like What list index is out of range? What the fuck are you talking about? Wait. Okay. Okay. At some point when it's iterating here, it goes over the 100. Why? Also, just to make sure, sanity check. Let's just do this. 98. Is this 49? Why is it saying 98? Fuck, dude, I'm so stupid. I put it a -1 as an old fucking... Oh, God, I'm so dumb. I think I'm not doing anything wrong here. There's nothing that's like, this shouldn't be causing any problems. And then, of course, I am just a big dumb idiot. Is it still 100? Still 100, okay. So is this the answer then? Not the right answer, my answer's too high. Okay. So, at least I've got something moving. Let's undo this now. Look at the final result and see if we can find out what the problem is. Okay. Let's go as pretty far down. Maybe all the way to the very, very bottom, but just to sanity check us. Here we go. Went up. Probably went down that previous turn. Okay, so let's also print the movement step. because none of the boxes here are broken, which is very positive telling to me. Okay, we're going to quickly refresh, as it seems like it's not having a good time. So you just want to kill the process. Also, I realize my keyboard hasn't been showing up this entire time, I don't think. Oh. Did I finally do it in? Is it finally unsalvageable? Did it finally give up the goddamn ghost? I think I broke it. I actually broke it. I finally did it. I finally got to do it. I broke quadratic. Okay, so let's quickly come back up and just open up a new quadratic HQ session, because I did copy all of the code before I left. So let's see if I can open up a new one. Should let me. Cool. And then oh, my browser is not happy with that. But it is working. Oh. Oh, that's really different though, because of yeah, that makes sense. Okay, cool. Yeah. This all looks correct. So I guess now all I have to do is the scaled up version of the larger example. So this is a larger example. I'm going to change the size to 10. Come here, paste this. Get rid of that. Whoa. Okay. I'm going to take this, and this is the smaller example I want to be able to put in. Because I have to, maybe once again, refresh the page, see if it breaks. Okay. Let me in here. Copy, paste. No, not the smaller example. Here we go. Okay. It is actually broken. That's incredible. It's actually so fucking broken. Okay. We're going to click HQ. We're going to open up another one. This time we're going to start by putting in the bullshit data. And now we're going to put this in after. With range 10, right? Yep. So, do I have the correct output at the very bottom? Wait, I get... This is not the right output. Okay. Let's see if this is the right output, though. Close that down. Delete this. Paste that. And this is now size 7. Okay. That's correct. So let's go to the very bottom and see where it fucks up. Nowhere. This is correct. Oh no. Whoops. Have errors, that's fine. So moves left and pushes that correctly, then down, then down, then right, then up, then left, then down, then up, then right, then down, then right to push them in line, then up, then down, then up, then down, then right. Again, then down it won't move, then left, then right, then down doesn't move again, then up, push all those, down, left, up, down, left under, up. Push that up correctly. Push right, push left, right, push left, right, down, left, down, left, right, up, down, up, right, up, left doesn't move, left doesn't move, right, left, down, left, down, up, up, down, right, up, down. It's just not doing anything here. Just a bunch of downs more than it needs to. The corner, up, right, up. It pushes them up successfully. down, up, up, right, doesn't do anything, left, left, right, 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 left, right, up, pushes it up successfully, left, left, right, left, up, pushes it up into the corner. Final solution has something in the corner? It does. Down, down, up, up, left, right, down, 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 left, right, successfully pushes it, left, up, up, down. It seems like a lot of these movements are nonsensical, but like this is working. Pushes them in line. I've got to examine to see what exactly is wrong with this. Pushes them in line with each other. Pushes them all over by one. Pushes them all together. This is exactly what it suggests it's supposed to do. Push all them down correctly. It did not push anything down here, as expected, as intended. I'm not miscalculating the output, I don't think. I don't see what the whole fucking... This is not what I get, and I'm not sure why, because everything looks correct. Is it just that I'm missing a move on the line breaks or something? These boxes are just not correct, like at all correct. But these boxes were. Okay. What I'm going to do is I'm going to do... I don't know why this is... Okay, so wait. I could figure this out backwards. Because it says that it's supposed to end up somewhere else entirely, right? What the fuck am I missing here? Is there like a single movement that's missing in each of these or something? I didn't... because they're broken across rows? I'll try something just to make sure. Does the movement end on left, left, up? Yes, it does. Does this movement end on left, left, up? Yes, it does. Print length of movement. There's 700. Did I print length of movement somewhere else? That's kind of funny, actually. Did see where I did that. Here we go. Okay, so 700. Is this correct, though? $70 times 1, 2, 3, 4, 5, 6, 7, 8. Cool. So it is absolutely 700 entries. So, the fuck gives? Why is this wrong? Is this how the scaled up one looks? 2, 4, 2 from the wall, 2 in the middle, there. Gap like L, vertical corner like that. What? Oh, sorry, yeah, that's after the first movement, because the first movement is moving it left. But yeah, that's right. I just don't understand what the fuck is wrong. I really just don't understand what's wrong. Like, it's working. It's working as intended. All the movement that I'm going through seems like it's correct. Okay, here's all that I can think of. Moves done equals this. Moves done plus equals movement step. Okay. This might do something weird. So, I'm going to kill this, kill this. I want to do moves done equals movement. Oops. 2 plus equals, my bad. They're not equal. Why? Why are they not equal? Oh, sorry. It should be print. This. So it is true. I'm doing literally every single movement that's in that list. So it is. They are equal. So I'm doing all the fucking steps. Then what is fucking wrong? Okay. Let's think of a situation that could break the board. What is a possible situation that could break this board? And I'll look to see if I can find a case where it happens. My best guess is that it's going to be something about pushing up multiple blocks. Okay, no. Oh, it's enjoying its time all the way up on the fucking... Okay, wait. And I need to also add in print movement step. There we go. Okay, nothing moves there. It tries to move up, and it does this successfully. Record a cool little terminal viz. This is one of the cases of that. Oh. Ah! Why is it not working? Dude, everything here is working as intended. It's actually, like, great how I fucking made it work. But then it says that it's wrong, and I can't see a single fucking thing wrong with it. I'm looking through it, and it looks entirely correct. Matthew, could you do me a favor before you go to bed? Let me know if you're still there. Could you do a terminal visualization of the large sample input? Ideally, it would be relatively slow. So you can, so that I could like, maybe it has like, maybe in like the corner, it should have like the all the individual steps, so that I could like pause it and then compare the step with something like relatively slow, so I can like fast forward, go to a specific step, and say, find out which step is breaking. Because this is driving me crazy. Because all of this looks correct. Aha! Ho, 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 ho. What is this? Why does that break? Why is that wrong? Something here is amiss. Yeah, no, the not the very yeah, the very first one they put in the thing here. Yeah. Oh, no, because the check blocks. We got rid of the check blocks up here, right? Because you no longer need check blocks of the tile we're going. Okay, wait. Okay, so it's column divided by 2. Oh shit. Okay. Um. I need to make it so that if the column dir is 1, it becomes 0. If it's 2, it becomes 1. So I just subtract 1, right? Oh no, because it's sorry. Column dir is either 1, -1, 2, or -2. I need them all to get closer. Oh, I could just divide by 2, right? I could just divide by 2 and then int it, and that would work, actually. Ah! Does it now have the correct output? It does! Ah, that was the bug. Okay. I would still like... Okay, so I've got the correct answer. Actually, I don't think I need it anymore. I think I just figured out my problem because I'm a big, dumb, stupid fucking idiot. I had an old bug that I didn't unfuck. And it caused problems. Uh-oh. I shouldn't have clicked on console. That was a mistake. I need to kill that, kill that, kill that. 1548815. What? 1548815. Fuck. But now the quadratic HQ is bugging out, so it's I put 1848815. Damn it. But that should be the correct answer now. I think this is the right answer. It's now breaking because it's doing that thing that it sometimes does, where it's like having a tantrum. Which is a shame because I hate that it does that, but it does do that fairly often. Quadratic HQ is a has its own little tantrums. One 1548815. That's the right answer. Ah! And it's still breaking. Ah, dude, Quadratic HQ is not the fucking tool for this job. I had to make 3 separate fucking spreadsheets to get that to work. Ah, I still want to see your visualization, though, and I'm going to go pull it up right now. Oh, that's so fucking cool. Does it really go, like, everywhere in this entire map? To explore that left little cranny that it hasn't quite touched? There's a little nook and cranny on the little left area there that it hasn't quite touched yet. The left and middle. Don't think it does. It's barely even touched the right at all, actually. Oh, there we go. A little bit of movement. Still staying pretty far up in that right corner. Okay, never really touches the bottom right at all. Cool. Oh, I want to bed. Thank you for watching. Hope you guys enjoyed, and I will see you all next time. I got it! I fucking got it!